Hi, this is a video demonstration of 7.2 uh, task. In this task, I am using the pre-recorded video that contains my hardware setup and Python code for the explanation. And this is the hardware setup for the task 7.2D. Initially, you can see the setup of GPIO. We are using GPIO 18 pin for this task. And when you come to def control it function, is used to control the LED based on the given command and update a label to reflect the LED status. And the logic of the function is to check if the command contains on. If it does, it sets the GPIO pin connected to the LED to high and turning it on. And if the command contain off, it set the GPIO pin to the low, and the LED turning off the LED. You can see the wall code here. And when you come to the diff setup GUI, and diff setup GUI function is used to set up a basic graphical user interface using the Thinker library in Python, creating the GUI window. Inside the function, I create a Thinker window by calling TK constructor, which create the main window object. It sets the title of the window to LED status simulator using the uh, title method, and creating the label widget. It creates the label widget to display the status of LED, and initially the label is uh, empty, and I use font size 18 and font style is Helvetica. The back method is used to add the label to the window and position it padding equal 20. This means adds vertical padding of 20 pixels around the label. And let's come to the definition command. Definition command function is to handle a voice command using the speech recognition library. It also initializes a Microsoft object. Inside the function, it creates recognize a object from the speech recognition library. Using this adjust for ambient noise of the recognized object. It adjusts for any ambient noise in the environment. This step helps improve the accuracy of speech recognition by reducing the background noise. And here I use through while loop, indicating that it continuously listens for the voice command until interrupt. Inside the loop, I try to capture the audio from microphone using the listen method of the recognition object, and it then attempt to recognize the speech from the captured audio using recognize Google method. And this recognize Google method utilize Google speech recognition API to the transcribe the speech into a text. And when it comes to handling recognize command, if a command is successfully recognized, it's called the control let function with the recognize command and the let status label parameter. This function is expected to control the LED based on the recognize command. And also, when it comes to the error handling, it uses error handling using try expert blocks. Moreover, if the speech recognizer fail to understand the audio, this uh, this unknown value arrow print the message indicate the failure. If there is an error with the request, the speech recognition API, uh, and it print the error message. And if the user interrupt the program with the keyboard, this method print the stopping message and break out of the loop. The overall of the function is to listen for voice command using the microphone, transcribe them into a text using the Google Speech Recognition API, and then control the LED based on the recognized command, which provide error handling to handle various failure scenario. And when you come to this final code, in this line, check the if the script is being run as the main program when the Python is executed, and the special variable name is set to the main if it is main program being executed directly, and the root that status label equals setup GUI. Then this line function to this line call the setup GUI function to create and configure the graphical user interface component, and it returns two objects such as the main window and the label widget. And from this line, create a new thread using Python threading module to execute the listen command function concretely within the main GUI thread. And when you come to the root.main loop line, this line starts the thinker event loop, which listen to the event such as a user interaction and update the GUI accordingly. The program enter into blocking state here, continuously running and responding to user input until the main window is closed. As a summary, according to this code, you can see the LED output, and when we say no, you can see our LED on a state. When we say off, our LED will be off. So let's move on to the let's check the final setup and the final result. On, off, on, off. So this is the end of my video demonstration. Thank you.